So hi, I'm Tony Bloch from the University of Michigan. Let me just see if I can share the screen here. So is that visible? Okay, so it's a pleasure to have this opportunity just to say a few things about Dan and his influence on my career and my general connections with him. So I'm at the University of Michigan in the math department. I've known Dan for a long time, both going back to his years at Michigan and more recently at Penn. And so it's been a wonderful connection, and that's certainly inspired some of my work, but it goes beyond that. So the first thing, in fact, I want to mention, people have described how Dan has influenced so many people as an educator. Well, one of the things he did, my son Mitchell was in high school in Ann Arbor, and Dan kindly invited him to work in his lab. And that was a wonderful experience at high school level. And Mitchell went on into EECS at Michigan. He actually majored in computer science, but this was a great introduction to research. And Mitchell's gone on now to work for Amazon Web Services in San Francisco. But this was a really nice thing that we've always been grateful to Dan for. So as far as the influence on me is concerned, so a lot of my work is, as you know, many of you, has been on sort of smooth systems, in particular Hamiltonian and Lagrangian systems, but in particular non-holonomic systems where you have systems that are constrained by non-integrable constraints. And a lot of my work sort of relates obviously to robotics, so those obviously describe things like wheel systems, but I've also become interested in recent years in systems that are non-smooth as well. So here are just a couple of things, and people of course have discussed these. So one of the things that you just heard a little bit about were navigation functions. So this has influenced some of my work on optimal control and navigation, some of my work with Peter Crouch and other people, where we've looked at optimal control of systems with obstacles. So you want to thread your way through a bunch of obstacles. And this was certainly inspired by Dan's work on navigation functions. On the hybrid or non-smooth system side, one can extend non-holonomic systems to systems with impact. In fact, if you generalize the definition enough, you can think of a system with impact as a kind of non-holonomic system with a one-sided constraint. So I had a really nice student recently called Will Clark, where we worked in general on hybrid systems and systems with impact, and I'll show you a couple of pictures in a moment. One of the other things I think about always when I think about Dan is pogo sticks. That's something that I associate with Dan, and this is, if you like, one-legged walking, but it's also inspired some work that I did with another students on bipedal locomotion. So we worked with Grizzle. I had another student called Hamed Razavi, and also we worked a little bit with Will Clark on this. So we came up with a stable motion for bipedal locomotion, and that was also a lot of fun. And another piece of work which is sort of indirectly related to Dan is some work that I've done with Matt Kvalheim, who was just mentioned, and you saw him talk a little bit earlier. So these are sort of biological systems where there are also discrete symmetries which arise both in walking and other systems, but in particular, if you look at some interesting work in biological systems recently, there are oscillations. So often you can think of a biological system as coming alive when there's a certain kind of oscillation, and the stability and the existence of periodic orbits in that case relate to the kind of discrete symmetries that Dan often thinks about. So that's been a lot of fun as well. So just to show you a couple of sort of pictures related to this, so I'll just cycle through these briefly. So that's my iconic non-holonomic. So that's a smooth system, and I'll show you how to hybridize it in a second. So that's a rolling penny. You can think of it as a wheel corresponding to a robot, for example. And one can say a lot about this, including its stability and integrability. Another system that I've also found a lot of fun to look at is the so-called Chaplygin sleigh, which is pretty much like a unicycle on a surface, where the center of mass is displaced from the contact point, and this has all sorts of beautiful dynamics. So you've seen a lot of interesting dynamics already today, but if you put a little oscillator on top of the sleigh, you get all these beautiful pictures, which remind me of my childhood interest in the spirograph. But in any case, you get a whole lot of nice and beautiful smooth trajectories. But you can also generalize this to the hybrid setting, and this is some work that I did recently with Will. So if you think of the wheel, you can think of it impacting the surface in various ways, but in particular, you can think of it as impacting some kind of surface, closed or otherwise. So this is the wheel. These are just pictures of the contact point of the wheel where it impacts a circle. And you can see again, it has a rather beautiful symmetric dynamic, which rather looks like the spokes of a wheel. And this is related to classical billiard dynamics. And in fact, you can change the surface in various ways and you get all sorts of other interesting dynamics. And in particular, for example, if I change the circle to an oval, I get a rather more complicated dynamics that does not look integrable. So we're not quite sure about that, but we're sort of looking at that at the moment. And this again relates to various things that Dan talked about, the relation where you have a system that's integral between impacts. I think of the pogo stick, you hit the surface, it's not integrable, it flies around, it is. So the interplay of integrability in hybrid systems, I think, is a fun thing to look at. And the last little picture I'd just like to show here is a little bit of bipedal locomotion. So this is the linear inverted pendulum, if you like, the lip, and this is sort of stable locomotion for a bipedal system that I looked at with Hamid Razavi and Jesse Grizzle. Anyway, it's been a lot of fun to talk, Dan. So again, happy birthday. And it's just been fun to be part of this and listen to everybody talking. So thank you. That's it.